Dear viewers, welcome to our online lesson. Today we look at Form 1 Mathematics. This is a continuation of our series of lessons that we are posting on our channel. Remember, as we had said earlier, we shall organize our channel into playlists for every form, in the sense that we have a folder in the playlist dedicated for Form 1 Mathematics, another one for the Form 2, Form 3, and Form 4. The same case with the chemistry. Welcome to our today's lesson. We look at solving simultaneous equations. Mathematically, we say these are linear equations that are solved by two methods, namely elimination and substitution. However, in the common language, we call them simultaneous equations. Straight away, let us go into understanding what you do in these approaches. I would like us to look at this topic in a very interactive manner, in the sense that after I give you one question, we work it out together, you'll have an opportunity to work a question on your own by pausing on the video. You work the question and then I'll provide the solution. Straight away, let us look at example 1. In example 1, we are going to solve the simultaneous equation solve the simultaneous equations given as 5a plus 2b is equal to 10 and 7a plus 3b is equal to 29. In this kind of case, whenever we are told to solve, we are looking for the value of A and the value of B. So how do we go about it? The best way to do it is to label this as equation 1 and this as equation 2. Then we select which of these two unknowns, is it A or B, that we would like to eliminate. Eliminate from the English word to get rid of. So we may choose either. If, for instance, we choose to eliminate, say for example B, the letter or the unknown with a smaller multiplier, then you realize we shall need to create the same multiplier in equation 1 for B and the same multiplier in equation 2 for B. So viewers, what do we need to multiply with 2 and 3 to make the same number? More or less the same multiplier. So if I multiply by 3, I'll get a 6 here. That means the whole equation becomes by 3, 15a plus 6b is equal to 30. I need to create a 6b here. So I multiply equation 2 by 2. That gives me 14a plus 6b is equal to 58. With that, we can easily now subtract. I will start with this one. 6b subtract 6b, I get a 0. So we have eliminated b. Now we are left with only one unknown. 15a minus 14a, we are left with 1a. And then on this other side, then we'll ask ourselves, what is 30 minus 58? And that gives us negative 28. So already we have established, we have found one value of a. And that gives us that if a is equal to 28, we are now going to substitute in one of the equations. Take, for example, we take 5a plus 2b is equal to 10. We substitute this 28 here, and we get 5 multiplied by 28 plus 2b is equal to 10. This is negative 28, so we get that as negative 28. So what does that come to? On your calculator, if you have one, or you do the multiplication, 5 times 28, that gives you negative 140 plus 2b, that gives you 10. We are using the first equation. So we eliminate this by adding, we add 140 on both sides. So that negative 140 plus 140 is 0. We are left with a 2b. 2b is equal to 150. And divide both sides by 2. Divide both sides by 2, we get that a b is 75. So after establishing that, it is very important that you highlight your solutions somewhere here. I can put them together, and I'll show that A is negative 28 and B is 75, so that clearly we can be able to see the solutions. It is also very important that before you leave this question, you should be able to check and verify that you've got it right. So we are going to check our answer by using the second equation, whereby we are checking, we check, are we right? 7, you multiply by negative 28, and then add 3 into 150. What is the expected result? So you find that that comes to be negative 796, negative 796 plus 450. Sorry, we are substituting 75, and that comes to be 225. Let's work that again. We have 28 multiplied by 7. We get, this is 56. We carry 5. This is 14. We have 196. Negative 196. If we add it to 225, it's the same as having 225 subtract 196. And what does that give us? That gives us 15, 9. This is 11, 2. That is 29. And that is the same value that we have there. That way, we have been able to check on our answer, and we are able to give that answer as correct. So viewers, as I had told you, I would like us to make this session as interactive as possible. I would like us to look at question number 2. In question number 2, I'm going to provide you with a question. You work on it. So we shall pause on the video, and then you will, I'll provide you with the answer. Question number 2 is here. We give question number 2 in the same way. Solve the simultaneous equation given that x plus 7y, question number 2, x plus 7y is equal to 8, and the other equation is 8x minus 6y. 8x minus 6y is equal to 2. Is equal to 2. So solve for x and for y. You kindly pause on the video and take about 2-3 minutes. You work on it, use elimination method, and then we shall resume. Welcome back. We continue with the question, and I want to believe that you have managed to work it out. In this case, remember we had said a learner is free to choose on either of the two parts to eliminate. Take, for example, after labeling each of these equations as 1 and 2, we decide to now eliminate the first x. So comparing the second equation and the first one, you find that this has a multiple of 8. So we can put a multiple of 8 here by multiplying the row out by 8. Equation 2, we don't change anything, so we shall kind of theoretically multiply by 1. We multiply by 1 to get 8. So 8 times 1x gives you 8x. 8 times 7 is 56y. 8 times 8 is 64. In equation number 2, we are multiplying the row out by 1, so we are left with 8x minus 6y, and that gives you a 2. Now, we normally have a simple mnemonic here, which says, when you find that the signs are same signs, subtract. So we are going to have a subtraction here, so that the 8x minus 8x gives you a 0. Then we are going to maintain the operation subtract, and we say 56 minus negative 6. So I do it here. 56 minus negative minus 6, and that comes to be 56 plus 6, which is positive 62y. So once more, 64 minus 2 gives you 62. And that gives us that 62y is equal to 62. Therefore, dividing both sides by 62, we get that y is equal to a 1. So you find that the two methods, substitution and elimination, work hand in hand. Only that now we are going to substitute the y is equal to 1 into one of the simplest equations, and we can opt for this one. So we move and we say x plus 7y is equal to 8. I have picked on the first equation, and that gives me x plus 7 into 1 is equal to 8. So in simple language, x plus 7 is equal to 8. Subtract 7 on both sides. What do we get? We get that x is equal to a 1. So in this case, we are getting that, as we had said, show your final answers together, pair them. When x is equal to 1, y is equal to 1. And before you leave your question, it is important that you check that your values are okay. We had used equation 1 in substituting for y. Let us use equation 2, whereby you have 8x minus 6y is equal to 2. So we substitute 8 into 1 minus 6 into 1, and we get 8 times 1 is 8 minus 6 is equal to 2. So that is correct. So viewers, that is the approach that we are calling on, or rather that we call a substitution. In our next example, we are going to look at elimination. How does it relate to substitution? Viewers, welcome back. In our example number 3, we are going to look at use of elimination method to solve the same pair of simultaneous equations that we had in example 2. X plus 7y is equal to 8. 8x minus 6y is equal to 2. So viewers, what we need to understand here is that we need to identify the simpler linear equation. The simpler linear equation can be obtained by checking on the pair. If you look at equation number 1, it looks simpler when we compare it with equation number 2. So we are going to pick on equation number 1, this one, and use it to join up or to be substituted into pause. Welcome back. Viewers, we move to example number 3, whereby we look at substitution method. In example 1 and 2, we had seen the use of elimination method. Now, we look at substitution. The question is, use substitution method to solve the pair of simultaneous equations given below. These are the same that we had used earlier, only that this time round, I would like us to use the substitution method. Now, in substitution method, we identify the simpler equation and we substitute it, as the word suggests, into the other equation. In geography, they say the smaller river drains into the bigger river. So our smaller equation is equation number 1. Now, one thing that we need to do to it is to rewrite it such that, given that x plus 7y is equal to 8, we can rewrite by making x the unknown, and we subtract 7y on this side and 7y on that other side. So we get 8 minus 7y. The x alone becomes 8 minus 7y minus 7y. Viewers, it is very important that you do not make the mistake of rewriting this as x is equal to 7y minus 8. The 7y is subtracted away from both sides, and so we get that. It is this portion here, part of x, which we shall substitute into this equation. Into that equation 2, whereby we have x, now we put this part. And that becomes, equation 2 becomes 8 into 8 minus 7y minus 6y is equal to 2. Now, viewers, I would like you to notice that the equation does not now have x, because the expression for x has been substituted with this part. So we open the brackets, we get 64 minus, that is 56y minus 6y is equal to 2. Put like terms together, where we have these two. So we get 64, and then we have minus 56, subtract 6y, that gives you negative 62y is equal to 2. Now, we need to put the like terms together. So we can subtract 2 on both sides. That gives you 62 minus 62y is equal to 0. We can shift this onto this other side by adding 62y on both sides. We add such that negative 62y plus 62y is a 0. That gives us 62 alone is equal to 62y. We divide by 62 on both sides, and that gives us that y is equal to a 1. This equation for y, we put it here. And so what does that give us? It gives us that x is now equal to 8 minus 7 into 1, and that gives us x is equal to 8. Okay, viewers, now once we get 1, y is equal to 1, we substitute this into this equation and we get x is equal to 8 minus 7y. Where we have y, we put 1, and that gives you that x is equal to 8 minus 7 into 1, and we get x is equal to 1. We need to once more pair them and say x is equal to 1 when y is equal to 1. So viewers, that is the approach that we are referring to as elimination and substitution. I would like us to do another activity, that is example number 4, whereby we shall have slightly bigger values. And we need to look at how we're going to do it. So I believe you are getting used to how we are doing it. I'm going to give you the question. You work on it, pause on the video 2-3 minutes, and then we need to discuss it. Before we go to that question, it's also important we look at the marking points. How would such a question be marked? you find that the moment a student is able to identify the linear equation, identifies what is going to substitute in the linear equation, this earns the student a method mark 1, the first M1. Now, we operate by opening the brackets and putting the right terms together until the student is able to get the first unknown correct, and there the student is awarded an M1. Then, after substituting the first unknown into the equation that the student had and obtains this one, we wait for the student now to get these answers as correct, and either at this point you can award an A1, or at this point you can award the A1. So basically, such kind of a question is a simple question, it's a short question, and we go for about 3 marks. So viewers, let us move on to question number 4, or example number 4, which I would like us to look at next. Question number 4. We are told solve the pair of simultaneous equations we are given 2x plus 3y is equal to 600. 2x plus 4y, x plus 4y, x plus 2y, x plus 2y is equal to 350. I read that again. 2x plus 3y is equal to 600. X plus 2y is equal to 350. Let us take 2-3 minutes. We work on this question, and then I'll provide you with the solutions so that we can match that with yours. Now, let's continue. I believe you have worked it out. And what are we getting? In this question, I would like us to look at the working first. Since we are not guided on which method, we can attempt to work it out by elimination first. We use elimination method. We work it out, elimination method 1, and then we shall check with substitution. Now, looking at these two equations, we can very easily eliminate x by multiplying equation 2 by 2, so that we create a 2x, similar with this one, and equation 1, we multiply it by just a 1, so that we maintain the 2x. What does that give us? That gives us equation 1, it remains 2x plus 3y is equal to 600, while equation 2 becomes 2 by x is 2x, 2 by 2 is 4y, and 2 by 350 is 700. And once more, we subtract 2x by 2x, it gives you 0. 3y minus 4y gives you negative 1y. 600 minus 700 gives you negative 100. And that gives us what? That negative 1y is equal to negative 100. We divide both sides by negative 1 to get us that y is equal to 100. Now with that, we can go back to one of our simple equations and find out the correct value of x therefore. So we get that x plus 2y is 350. We have the value of y, so we put it in here as 2 into 100, and that gives us 350. That gives us x plus 200 is 350. We subtract 200 from both sides. we subtract 200 from both sides, and that gives us x is equal to 150. And once more, we need to pair them. We pair these answers, and that gives us x is equal to 150, while y is equal to 100. So viewers, it is important that since now we are conversant with elimination method and substitution method, a learner is free to use either, especially when you have not been dictated on which approach to use. Take for example, that student or that viewer who would like to use the substitution method, which is method 2. So we have discussed and said identify the simple equation out of the two, and that happens to be equation 2. So we're picking on equation 2 as x plus 2y is equal to 350. We can push this onto this other side so that it gets x is equal to 350 minus 2y. Now with this as the simple equation, we shall match this with that and say 2x plus 3y is equal to 600. Now, as we had said earlier, this part x is the one we are going to substitute at this point. And that gives us what? That gives us 2 into 350 minus 2y, that is the value of x, or that's expression for x, plus 3y is equal to 600. Viewers, as you can see, we have the equation now with one unknown. So opening the brackets, we get 700 minus 4y plus 3y is equal to 600. Put the like terms together. Negative 4y add to 3y comes to be 700 minus 1y, which is equal to 600. We put like terms once more together, whereby we can subtract 700 from both sides. We are left with negative 1y is equal to negative 100. And that way, we divide by negative 1, both sides, by negative 1, and that gives us y is equal to 100. It is this value of y we are going to put in our earlier equation, which had read x is equal to 350 minus 2y. And that gives us what? That gives us that x is equal to 350 minus 2 into 100. And that gives us that x is equal to 350 minus 200 is 150. And once more, we are able to put the two values together for x and y, and as we had said, we pair them for simplicity during marking. If we look at how the award of marks is done here, you'll find that we start with this one, where the learner is able to identify and successfully subtract to get such kind of a result, then we get an M1. Now, where the student is able to get one of the values correct, ready for substitution, then gives you A1, and for the final answer, A1, and that awards the learner 3 out of 3. In this other case, we have the successful substitution of the simple equation into the other equation, that gives you M1. And when the learner is able to get the first result correct, that is M1, it's a correct method, and that method shown in getting the answer for x, and that gives you A1, and that also earns the learner 3 marks in such a short question. So viewers, I would like us to move to question number 5, which we will look at in terms of bigger values and different approaches to this. Viewers, welcome back. We look at question number 5, and it reads, a trader bought two types of bulbs, A and B, at shillings 50 and 56 respectively. So A costs 50 bob, B cost 56. She bought a total of 50 bulbs of both type A and B. A total of 50 for both type A and B. For a total of shillings 2,692. Determine the number of type A and type B bulbs bought. So viewers, in this kind of a question, we can use the unknowns X and Y, whereby we can say, let number of type A be X and type B be Y, such that we develop some quadratic equations. We develop some simultaneous equations, I beg your pardon, whereby for the first statement, she bought a total of 50 bulbs, we get X plus Y is equal to 50. She bought a total of 50 bulbs, so the X and the Y are totaled 50. Let us look at now the pricing. If the number of X bulbs, type A bulbs were X, therefore they must have cost 50X. What was the cost of type B bulbs if they were Y? That must be 56Y, and that totals 2692. So that creates for us equation 1 and equation 2. Now, we look at a way of solving the two, and viewers, we can pick on either elimination or substitution. Supposing we pick on elimination, and we agree to eliminate X. That means to equation 1, we shall multiply by 50, and equation 2, we multiply by 1. And that gives us what? And that gives us 50 multiplied by X is 50X plus 50Y. That comes to be 50 times 50, 2,500. Equation 2 remains as it is 50X plus 56Y, and that comes to be 2692. We subtract the 2, and 50X minus 50X gives us a 0. 50Y minus 56Y gives you a negative 6Y. Then we have 2500. If we subtract 2692, that gives us 100, negative 192. If we divide both sides by negative 6, you get that 1Y is equal to 32. Then we substitute this in the simplest equation, equation 1, X plus Y is equal to 50. And so we bring in the 32 here. X plus 32 gives you 50. Therefore, we get Y is equal to 32. We substitute this into the simpler equation. X plus Y is equal to 50. And we get that X plus 32 is equal to 50. And that gives us that X is equal to 50 minus 32, which is 28. As we had said earlier, pair your answers as X is equal to 28 and Y is equal to 32. Do a cross check. X plus Y giving you 50, and also we can check onto this one. So viewers, we are now quite conversant with the situations whereby we have two linear equations and you need to solve them together, or rather simultaneously. The methods are substitution and elimination. This is a method. In mathematics, we call this methods, and they can be used in other branches of mathematics in solving where a situation whereby an equation has two unknowns. Viewers, we come to the end of our online lesson. I thank you for your participation. I would like you to participate more by putting equations that could be challenging you on the comment section. Share this video, subscribe so that any moment I post a new one, you'll be the first one to be notified. In Form 1 Mathematics, we had promised that we shall be having other topics coming up. And in the next video, we shall be looking at Commercial Arithmetic 1. That is also a challenging area to most learners in terms of currency exchange, in buying foreign currencies and selling foreign currencies, and some bit of commission. Thank you, and let's meet next time.